Hey everybody, today's lesson is on arithmetic sequences. An arithmetic sequence is a sequence of numbers in which consecutive terms have a common difference. So here's an example of an arithmetic sequence. 5, 12, 19, 26. It's a sequence of numbers, and any two numbers in a row, consecutive terms, have a common difference, meaning if I subtract 12 minus 5, I get 7. If I subtract 19 minus 12, I get 7. I subtract 26 minus 19, I get 7. So this common difference here, which we use variable d for, the common difference is going to be 7. D is equal to 7. This right here is called the rule for the nth term of this sequence. So this rule gives me this sequence. So for instance, if I want the first term of this sequence, I plug in 1 for n. 7 times 1 is 7. 7 minus 2 is 5. If I plug in 2, I get the second term. 7 times 2 is 14. 14 minus 2, 12. Third term, plug in 3 for n. 7 times 3 is 21. 21 minus 2, 19. So this is called the rule for the nth term right here. So this is what we're going to be doing today. I'm going to be giving you a sequence and asking you for the rule, or vice versa. But again, a couple notations again. So this D, the common difference is 7 here. If I ask you what is the first term, A1 is the first term. It's an A with a subscript 1. So A1 here is 5. The second term, A2 is 12. The third term, A3 is 19. So this tells you that this is the notation for the number term of the sequence. First term, second term, third term, fourth term. And you can probably guess the fifth term of this sequence. If I add 7 again, 26 plus 7 is 33. So the next number here would be 33. And a couple of formulas here. This is going to be how we find the rule. This is how we find the rule. To find the rule, you take the first term and you add that to n minus 1 times the common difference. This is what we're going to use. This formula is what we're going to use to write the rule. To find the common difference, you just subtract any two consecutive terms. So here we did the second term minus the first term was 7, or the third term minus the second term, or the fourth term minus the third one. This formula just means subtract any two consecutive terms to get the common difference. And this formula we're going to use for number 4. This is going to help us find the common difference if I give you two numbered terms. But we're going to use this. We're going to use this for number 4. All right. So let's start with number 1. So here's a sequence: 3, 7, 11, 15, ... So we want to write the rule for the nth term. So we're going to use this formula. So an equals a1 plus n minus 1 times d. To write the rule out, we just have to plug in the first term, and we have to plug in the common difference, and then we're going to simplify, and that's going to give us the rule. So let's go. So let's look over here. What is the first term? Well, a1 is the first term. The first term is 3, right? So a1 is equal to 3. What is the common difference? So let's look. Subtract any two consecutive terms. 7 minus 3, 4. 11 minus 7, 4. 15 minus 11, 4. So I know that D, my common difference, is 4. So now I'm going to plug in 3 here for A1. I'm going to plug in 4 for D. And I'm going to simplify, and that's going to give me the rule. So AN is going to be equal to A1, which is 3, plus n minus 1 times 4. I'm going to distribute the 4 over here. So AN is equal to 3 plus, if I distribute the 4, I get 4n minus 4. And now combine like terms. 3 minus 4 is negative 1. So AN is 4n minus 1. This is the rule. This is the rule. So the rule is AN, any term, is going to be 4n minus 1. Let's check to make sure that this is the correct rule. If I plug in 1 here, I should get 3. 4 times 1 minus 1 is 3. If I plug in 2 here, I should get 7. 4 times 2 minus 1, 4 times 2 is 8, 8 minus 1 is 7. So this works. This is the rule. Now I want A25. This just means the 25th term. So I'm going to use this rule to find the 25th term. Just plug in the 25 for n. So the 25th term, so A25, is going to be 4 times 25 minus 1. 4 times 25 is 100, minus 1 is 99. So the 25th term of this sequence, if I kept going, if I wanted to count the 25th term, it would be 99. All right, let's do the same thing now for number 2. Write the rule. So I'm going to use an equals a1 plus n minus 1 times d. I just have to plug in the first term and the common difference. What's the first term? The first term is right there, 9. So I know that a1 is equal to 9. What's my common difference? So I got to subtract consecutive terms. 4 minus 9, negative 5. Negative 1 minus 4, negative 5. Negative 6 minus negative 1, negative 5. So my common difference here is negative 5. The numbers are going down. When the numbers are going down, your common difference is always going to be negative. So plug in a1 and plug in d. So an is equal to 9 plus n minus 1 times negative 5. I got to distribute the negative 5 here. So an is equal to 9 plus, that's going to be negative 5n plus 5. 9 plus 5 is 14. So the best way to write this is going to be an equals negative 5n plus 14. And this is my rule. This is my rule for the nth term. So an equals negative 5n plus 14. Let's check to make sure it's right. If I plug in 1, I should get 9. Negative 5 times 1 plus 14 is 9. If I plug in 2, I should get 4. Negative 5 times 2 is negative 10. Negative 10 plus 14 is 4. That works. So now I want to find the 30th term. The 30th term of this sequence. So just plug in 30 into the rule. So A30, the 30th term, is negative 5 times 30 plus 14. That's negative 150 plus 14, which is negative 136. So the 30th term of this sequence is negative 136. First term, second term, third term, fourth term. If I continued all the way to the 30th term, I would get negative 136. Number 3, this is an easy one. Write the first 4 terms. So I give you the rule. So what's the first term? Plug in 1. 6 times 1 is 6. 6 minus 1 is 5. Next term, plug in 2. 6 times 2 is 12. 12 minus 1, 11. Next term, 3. 6 times 3 is 18. Minus 1 is 17. Plug in 4. 6 times 4 is 24. Minus 1 is 23. There's my first 4 terms. Now the last one. We want to write the rule for the nth term that has the given terms. So I'm telling you that the 20th term is 45. The 32nd term is 81. But I want to write the rule. Remember, to write the rule, you need to know 2 things, A1 and D. Right now, I don't know either of those, but I can get the D by using this formula here. AN minus AM divided by N minus M. So AN minus AM, those are the 2 terms of the sequence. AN is the later one, so it's going to be 81 minus 45. So D equals 81 minus 45 over N minus M. That's the 32nd term minus the 20th term. 32 minus 20. So 81 minus 45 is 36. 32 minus 20 is 12. 36 divided by 12 is 3. So my common difference is 3. Common difference is 3. I still have to find A1. So how am I going to find A1? Well, I know the 20th term is 45, or I know the 32nd term is 81. I'm going to use one of these. I'm going to use this one here. So I know when n is 20, the number term is 45, and I know the common difference is 3. I'm going to plug all that in, and I'm going to solve for A1. This is the hardest part. So here is I'm going to plug in 45. n is going to be 20, because that's the 20th term, and I know the common difference is 3. And I'm going to solve for a1. So 45 is going to go in for an, equals a1, plus 20 is going to go in for n, that's 20 minus 1, times d, that's what we just found, d is 3. 20 minus 1 is 19. 19 times 3 is 57. So 45 equals a1 plus 57. So subtract 57. 45 minus 57 is negative 12. So my first term is negative 12. So now that I know my first term in D, I can plug in here to write the rule. So an equals the first term, which is negative 12, plus n minus 1 times d, which is 3. Distribute this 3. So an equals negative 12 plus 3n minus 3. Negative 12 and negative 3 is negative 15. So 3n minus 15. And there we go. This is the rule. This is the rule for these two terms. All right, guys, hope you're doing well. I'll be on later on Zoom if you have questions. We can redo this problem if you want. I know this is the hardest one. Stay safe, be well, ask me questions, reach out to me and Remind, Google Classroom, email. I'm here for you guys, all right? Talk to you soon.